And these are word clouds, so the more responses of the same one, the bigger the word gets, by the way. And you can add in more words than just the one. So we're getting some good words. Engineers typically are problem solvers. And I don't know if I ever have I given you the definition of the difference between a scientist and an engineer in this class? All right. My favorite definition of the difference between a scientist and an engineer was a quote by someone who compared Mr. Spock with Scotty in Star Trek. Most of everybody's familiar with Mr. Spock and everybody's familiar with Scotty, right? All right, Mr. Spock, in his case, he was done when he had proved it to himself that it was theoretically possible. So at that point, he was finished. When it was theoretically possible, he had done his job. Scotty, on the other hand, had to make it work in a time fashion and such that they could get out of the terrible situation, and had to do it without wrecking the ship. So he had to actually put into place and make those principles work and balance all of those different aspects. So Scotty was the engineer and Mr. Spock was the scientist. So that's a really good definition of the difference between scientists and engineers. Now, that doesn't mean that you can't come from a science background and do engineering, because you all know that my PhD is in physics. It is not in engineering. But I worked for 25 plus years as an engineer. I do not have I do not have my PE license. I chose not to do that. I do have a certification. My certification is a registered environmental manager, but I chose not to go for my professional engineering degree or my professional engineering certificate, because I would have had to have gone back and taken the EIT. I wasn't grandfathered in. And by the time that had happened, I was so many years out of school to study for the EIT when I had been working, and I did not have to have a professional engineering license in order to do my job. I just chose not to do it. But that was one of the things that you have to think about in terms of that PE, which is an advantage of the VEL program, by the way, because in order to go from your engineering training, which is also now called the Fundamentals of Engineering exam, which a lot of you will have to take before you graduate with an engineering degree, that between the time of that and your sitting for the professional engineering license exam, you're looking at 5 years of work experience that you have to have. With the Bell program, you walk out of there with 2 years work experience, so you're only talking 3 years between the time that you have to go forward to where you could sit for your professional engineering license. So you've got some things that, and like I said, most engineering schools now require you to take the FE exam before you leave school. I do have in your resources the FE exam handbook, which is a very valuable book to have. I will start letting you guys use that handbook on exams in my engineering classes. So if you wanted to go ahead and get your exam or your handbook ordered or printed out, because you can make it available as a PDF, I would suggest doing so. The other thing that we have and have done for you all, if you are interested in getting it now, I will get you the information, but we have SolidWorks licenses for everybody that in our pre-engineering program. We have SolidWorks also installed on the computers over in the computer lab, the process technology computer lab in Herald, but I can get you all a license to the student version of SolidWorks, which is an engineering design software. If you're going to the Bell program, you need to go ahead and take your certification test, because we actually have licenses to sit for the test in order to get that certification. And then you can use that, and I do know of internships within this area in Enid and in Tonkawa that if you have a SolidWorks credential, they will hire you to help. So if you're interested in getting SolidWorks installed on your computer, holler at me and we can get that going, because we do have licenses for everybody. And by the time you get to statics, which is your graduating semester, I like for you to use SolidWorks to help out with your engineering design projects. And SolidWorks is one way engineers are going to communicate. And when we start talking about drawings are a major way that we communicate with each other, in addition to the lovely memos that you guys have been doing. So I'm going to go back to my polls. And then it's time to ask, because we are halfway through the semester. Can you believe it? We are actually halfway through the semester. I want to go back. Nope, go back. I want to duplicate it. We're going to do that. Get rid of that. Duplicate it. Activate it. Open it up. So, I want to know so far what you've spent most of your time in this class. And this time, you just text in A, B, C, or D, or E, because I got 5 different choices. And just for grins and giggles, last week I wrote over 25,000 words. I keep track of my daily word counts. I have a piece of software that I actually use to help me with that. And between emails, columns, a couple of different things that I'm working on for writing, I did over 25,000 words in the last week. Now, that's not bad, because in one case I get paid $1 a word. So for one of my columns I get paid $1 a word. Unfortunately, it caps out at about 1,000 words, but 1,000 words, by the way, a page in a magazine. So if you get Car and Driver, you get Popular Science, you get some kind of magazine like that, a page is about 650 to 700 words. So to actually write for a magazine, you're talking a single page is about 650 to 700 words. So 2 pages is about 1,200 to 1,500 words. So if you start thinking about what journalists do, and you're talking about an inch of type or an inch of column space, it kind of gives you an idea of how many words that you have to use. So writing is a form of communication. The memo is only one. The memo is only one form. If we go into chapter 4, they're going to talk about the memo. We will talk about email, because my understanding is email is now formal business communication, which means your emails are critical. All right. So email is a form of business communication. You have to worry about it. So if you're writing email, because it's considered formal business communication, you're going to want to make sure, A, you've spell checked it. B, you've looked for proper word usage. Okay? Because remember that we have words that are synonyms and our fingers fly off. Sense and sense. Alright? Sense is S-I-N-C-E and sense is S-E-N-S-E. Spell check does not catch proper spellings of wrongly used words. Although Word does have a pretty fair grammar checker. It's not the best, but it's fair. The other thing is that in our technical writing, we use third person. So we would say the experiment was done instead of saying we performed the experiment. And that also puts our tense into passive tense, which things like Word is going to flag as passive tense. But technical writing ends up in passive tense a lot. So that those grammar things that you thought you could get rid of don't go away. The other thing that we have to worry about, particularly for you all that are going into engineering, is the non-formal business communication. Things like instant messenger, messaging off of Facebook, the WhatsApp app, the Twitter feed, Instagram, Snapchat. Even though you think that you may have deleted it, or that Snapchat has deleted it, or that Twitter, or you have retracted it from Twitter, or you have pulled it off of Facebook, it is still out there in the ethos, in the Ethernet of the internet. Nothing ever truly goes away. And if you're really good, you find out that you can backdoor into people's websites. And you don't even have to be trying hard. So even if it's behind a firewall, sometimes there's a backdoor to that firewall that doesn't prevent certain things. Employers, future employers will go out and look at your social media feeds. So if you are trying to get a job at a company that is straight-laced, okay, there used to be, people used to talk about IBM as the guys who wore all the blue suits and were very stiff. If you talked about stockbrokers, there were companies that were very, very stiff and conservative. If you think about your past social media, you may want to reconsider, because companies do look at it. Now, it doesn't help that we have current political people that use Twitter inappropriately and would drive you crazy. And what's really bad is people who work for him, he's going to check their Twitter feed. So you can sit there and you go, okay, it really is strange examples, but if we go back to ethics, then it becomes a thing that we have to look at. So you actually have to watch what you put out on Twitter, what you put out on Facebook, what you put out on any of your social media, whatever the current social media is, you have to worry about it. And you have to worry about what's in your email. I will give you a for real example. I was working at one of the refineries as an environmental person in environmental science. We are trying to stay in compliance with an environmental regulation. It was a brand new environmental regulation, so there was lots of back and forth with the agency as to how the regulation should have been interpreted. The idea was we were to have this analyzer on a stack to monitor sulfur emissions from the stack. The monitor was supposed to be up 24 hours a day, 7 days a week, 365 days a year. But the technology at the time was such that that instrument that we had, although it was in a case and supposedly in a weatherproof case in a house that's out there on the stack, the technology was such that it was designed for laboratory conditions. So think about that for a second. I've got a laboratory instrument that's now outside in a plant that's now setting 100 feet off the ground, that is pulling a sample from 200 feet off the ground. So I have 100 feet of stainless steel piping that I have to worry about, not to include the calibration gases that I had. And that instrument was out in all kinds of weather. And then where we were at the time, there was snow, ice. We actually had 4 seasons. And that instrument was supposed to operate 24 hours a day, 7 days a week, 365 days a year, with only 5 minutes of downtime for calibration checks per day. Anybody who's ever dealt with delicate instrumentation knows that that's very difficult to do. And the technology at the time said my laboratory instrument could barely be up that long. And we were trying to find why this instrument wouldn't stay up and wouldn't continue to work. So we had the operations manager, the instrument technicians, myself, several other people, the manufacturer of the piece of equipment, trying to figure out why we couldn't keep this piece of equipment up and running. So we were trying to do this, and I actually wrote an email to the operations manager and said in my email that we had tried all the low-hanging fruit in order to get this particular piece of equipment up and running. Meaning, or intending to mean, that we had tried all the logical little things short of replacing the instrument. 2 years later, EPA sues us for not having the instrument up and running 24 hours a day, 7 days a week, 365 days a year. Subpoenas all emails related to the instrument. That email gets picked up. I am sitting in a deposition being asked, what was the low-hanging fruit? And why didn't you try something else? And where's the evidence that you did try something else? Because we never followed up on that email. We followed up in a meeting, but there were no minutes to the meeting, so EPA said the meeting didn't take place. We followed it up with a variety of other things, but no, I was questioned about that email. Did it mean I was trying not to spend money to fix that instrument? Was I trying to skirt compliance? No, I wasn't. But the email made it sound like I was. So you've got things that you have to worry about in your communication. So now if you do that email, think about it for a second. My biggest fault in that email is I used a euphemism, low-hanging fruit, meaning, okay, we've tried all the cheap stuff, now we got to get to the expensive stuff. And I got questions on that. So now if I had been inappropriate and used explicatives associated with my lovely instrument, which I wanted to use explicatives with lovely instrument, think about how that would look in a deposition. It's not stuff, as a young engineer, way back when, it's not something we necessarily think about. But I will tell you that even the most innocent thing in an email can come back to haunt you. So, if you're writing emails and you never write an email angry, well, take that back. You can write all the emails angry that you want. Just don't send them. If you are upset and are dealing with something, you can write it out, you can get ready to send it, but don't hit that send button. Because trying to retract it is a pain in the tush. And then it can come back to haunt you. It can come back to haunt you. So when we write things, we have to be very, very cognizant of what it is we're doing. So emails, texts, Facebooks, all of those things are communication, and all of those things can be subpoenaed, and all of those things can be part of the documentation record. And depending upon what you're working on, you may have to be very aware of how that works. For example, I was actually the environmental engineer for the company that was in a criminal case. The company had been found criminally liable for some environmental mishaps, and it was previous owners, but the company that was taking care of the settlements had to have those things. So everything that I wrote, everything that I texted, everything that I had was subject to the courts. So you have a lot of various liabilities associated with it. So if you think about all of those notes, all of those texts, all of those pieces of information, every email had to be kept and documented because it was under a court order. So those are aspects that you don't necessarily think about. So we have general communication, just normal correspondence, email, memos, because that's the next level. Then you have technical reports. You have engineering reports. You have all kinds of technical documentation. If you're doing computer science monitor or computer science engineering and you're writing code, all your code is a form of communication, and all the documentation for your code is a form of communication. Then you have all your drawings, and so we have a whole host of communication pieces that we have to worry about. So we have lots of different things. So I'm going to jump over into week 7 so that you can start seeing where we're at. So this week's expectations is looking at our communications chapter. And down here below is the degree planning sheets that we have. Again, we have a couple of other degree planning sheets. They may be more appropriate for what you're doing. Mathematics, maybe one that you might want to look at. Or you may want to go and look at the Associates of Applied Technology and Process Technology. That may be one that you want to fit. But this grad check is the grad check for the pre-engineering document. I definitely want you to have that in, and that needs to be in by Friday, close of business. Your grad check form has to be in Friday, close of business. There isn't a memo this week, guys. Because you have a test next week. And the test is going to cover chapters 1 through 4. Okay, so if you're looking at the chapters 1 through 4, things like what makes a good team member, things like what makes traits of good engineers, types of communications, things that we've been talking about, different areas of engineering, why codes are important, why time management is important. Those are the kind of things that I'm going to be testing over, right? So it's chapters 1 through 4 in the book. So anything's fair game in chapters 1 through 4. Anything's fair game on the discussion boards. So if you haven't flipped through the discussion boards, you probably want to do so. Particularly on the time management and traits of the engineers. And then, so if I go over here to my discussion boards, let's look at them real quick, just so you guys are all in there. Study habits. What are good study habits? We've got standards and codes, current, newsworthy, and topical type issues that have been out there for engineering. Elon Musk just did SpaceX. Kind of interesting thing is the stainless steel that he's talking about, that actually made the news, the type of stainless steel in the rocket for SpaceX.
I found it more interesting that he's going to be pulling CO2 from the atmosphere.
Well, we'll see if that works. Climate change has been a big one. It's interesting. I've been following a number of my American Chemical Society type folks in this whole climate change stuff. Speaking of which, on October the 22nd, the American Chemical Society puts out something called Program in a Box, and we will be subscribing to it via feed, and I will be getting rooms over on the Enid, Stillwater, and Tonkawa campuses to do program in a box, and it's on metals because it's going to happen during National Chemistry Week, which is the week of October the 21st, because it has October 23rd in it, and everybody knows what October 23rd is, right? Oh, come on. 6.022 times 10 to the 23rd is a what? It's a mole. So October the 23rd is mole day. And if you really want to have fun, you celebrate it at 6:02 in the morning. Not me. I've never celebrated at 6:02 in the morning. We used to have somebody here on the Tonkawa campus that would buy everybody as something at McDonald's at 6:02. If you were there at 6:02, you got something at McDonald's. So it's mole day. Actually, but next week actually has 2 days. October the 9th. Anybody have any idea what October the 9th would be? Nanotechnology Day. October the 10th. Metric Day. Yeah, October has lots of interesting science holidays. Nanotechnology Day is pretty cool. There'll be stuff about Nanotechnology Day. That's next week. And then National Chemistry Week. And the theme for National Chemistry Week this year is marvelous metals. And looking at various aspects of metals. And each year they celebrate a theme. They've been doing it for a while now. They've been doing it for quite some time. But National Chemistry Week is coming up. So on October the 22nd, in the evening, they will do a nationally internetized webinar on marvelous metals. And we've participated in these program in a boxes for a while. They've done things like the periodic table. They've done things on opioids. They've done a variety of different things. This one just happens to be metals. So and I'll put information out on that one. But those are things that we've got in here. Also be aware, if you haven't picked your book, you probably ought to be doing so that you have an opportunity to read it, to make sure that comes in and get that piece going. So next week, test. Friday, your degree plan. And by next Thursday, I want to talk with everybody about their degree plan. And the test won't be that bad, okay? The test isn't going to be that bad. And then we will be looking at, but one of the other things that I want to point you to, because it's right here, this is probably the best resource that I have found for engineering symbols and drawings, because there are such a host of different types of drawings that we use. And depending on what your particular engineering field is, will depend on which one of these drawings you will use the most. I probably have done more piping and instrumentation diagrams than I care to ever want to think about. And I can even tell you that different companies handle their piping and instrumentation diagrams differently. And that's going to tell you, if you're in the chemical engineering field and you're working in refining or you're working in pipeline, these become critically important, because that not only tells you which equipment that you have, because it's going to show all of your equipment, it's going to show the flows of those equipments, and it will give you pressures and temperatures and where the instruments are. So piping and instrumentation diagrams, while they're not built to scale, they're definitely built relative, so you can tell and find pieces of equipment in the plant. So they're very, very critical types of drawings. So P&IDs are very important for the chemical processing, natural gas, petroleum industries, as well as pharmaceutical industries when you're in major production. Electrical diagrams Those are going to be important for just about everybody, but most of the time people who are working with those electrical diagrams are in information technology, communications, control systems, electrical engineers. Those types of diagrams are going to be important for them, and they'll use them a lot. You'll get logic diagrams if you're coding, if you're programming. You'll also get logic diagrams in control systems. So you'll get different logic diagrams. I think I may have only picked up 2 or 3 logic diagram type program or diagrams over my career, because that's not where I played. But if I'm working with an instrument tech, that instrument tech was probably using his logic diagrams quite a bit in order to make sure that the instrumentation was working properly. You've got fabrication, construction, and architectural drawings. Those are your plans. Those are your construction plans. You can have plot plans where things are going to be positioned. You can have assembly drawings. You can have isometric drawings, which are drawn to scale. And isometric drawings are usually building drawings for plants. So you'll have, and those are important when you're putting the puzzle pieces together. One of my challenges with my unit is when they built the vessels, somebody didn't pay attention to how they were going to be put together on the skid. So the manway on my vessel was actually built in the wrong spot, so we had to flip the vessel around during construction because somebody didn't read the isometrics. And the manway was put into between the 2 bullet type tanks where you only had 6 inches to spare. There was no way a person was going to be able to open it up and get inside the vessel at clean out time. So we had various issues. So we have hosts of drawings. And I will probably be posting a discussion question on what types of drawings that you may have encountered, because every one of you has encountered a drawing I am positive of. And we'll talk about those when we come back from the test. Any questions, anything else that you guys want to ask before